Okay, so hazard symbols that contain this logo, this means that they are flammable. So they always try and give you a picture that helps you visually to understand what it means. Give the names of the elements that will combine to form barium sulfide. So we're obviously going to have barium. Now because it's sulfide, we will actually need sulfur. So you've got barium and sulfur, and you've got to get both right there for 1 mark. Okay, barium is toxic. Explain a precaution that you would use when handling it. So I think that there's a few different answers to this. I'm just going to give you one for now. So if I was doing that, I would wear gloves when I'm handling this. And why am I doing that? So it prevents contact with skin. Okay, so give what you would do and give the reason why you would do that. Okay, next one here. We've got a beaker of barium chloride and sulfuric acid were placed on a balance, as you can see here. And the total mass of these two at the beginning was 25.7. They've then poured the sulfuric acid into the barium chloride into one beaker, as shown here, and it wants to know after the reaction's taken place. We get a white precipitate, and it says state the mass on the final beaker. Well, this requires us to remember that the law of conservation of mass says that mass cannot be created or destroyed. So the mass is going to be the same, it's 25.7. Then it says give the name of the white precipitate formed when you do barium chloride with sulfuric acid. So whenever you have sulfuric acid, you always make a sulfate salt, and the metal gives the first name. So this is called barium sulfate. Okay, next question. This undergoes electrolysis. Sodium chloride undergoes electrolysis, as shown in the diagram here. So what we've got is a DC power supply. Got my electrodes, and then here's my solution of sodium chloride. It says state why sodium chloride solution rather than solid must be used. So this requires the knowledge that when it's in a solution, the ions are free to move. If you remember, when it's a solid, then this is where it's in an ionic lattice, and that means that the ions are held in place and are not free to move. The formula ion is present. We've got those here. Circle the ion to be attracted to the anode. So the anode is where the anions go, and the anions have a negative charge. Okay, so the ones that will go to the anode are going to have a negative charge. So we will have the chloride ion and the hydroxide ion will be the ones that go that way. Molten lead bromide can be electrolyzed to form molten lead and bromine gas. Explain how the student could modify it to carry out the electrolysis to do this. So what we've got to do here is get our lead bromide in a molten state. So if I was going to do this, we would need to have a way to heat up the lead bromide, and the best way to do that would be in a crucible. So I'll put here, so we use a crucible rather than the beaker, and we would heat the crucible so the lead bromide becomes molten. Okay, 1 mark for each of those 2 facts. And I think that is the end of